If you picked up a Hasselblad in 1955, the shutter inside it was built by Friedrich Deckel. If you loaded a Rollei, a Zeiss Ikon, a Kodak Retina, or a Voigtländer pneumatic, the shutter was built by Friedrich Deckel. For the better part of the 20th century, one factory in Munich, Germany, controlled the device that let light hit film on almost every serious camera on Earth. Shutters accurate to 1,000th of a second, assembled by hand, powered by clockwork gear trains smaller than a fingernail. The name Deckel meant precision, so absolute that no competitor could touch it. But that same precision, that same obsession with microscopic tolerances, also built the fuel injection pumps that powered the Focke-Wulf 190, one of the most feared fighter planes of the Second World War. And inside the factory where those pumps were assembled, a man named Hans Hutzelmann was secretly working to destroy every single one of them. This is Trade Archive. If you're the kind of person who wants to know what actually built the modern world, hit like and subscribe. Jungingen is a small municipality in Baden-Württemberg, southern Germany. In 1871, it was farm country, and Carl Deckel was a small farmer and trader raising a family there. His son, Friedrich Wilhelm Deckel, was born on December 11th of that year. There was nothing about Jungingen that suggested a future in precision engineering. But Friedrich showed an early mechanical gift, and after completing an apprenticeship in a local workshop, he did something that would define his entire life. In 1889, at 18 years old, he went to work at Carl Zeiss in Jena. Zeiss was not just a lens company. It was the epicenter of optical science on the planet, and the man running it was Ernst Abbe, a physicist whose standards for precision were borderline pathological. Abbe personally supervised the young Deckel as a laboratory mechanic, and what Deckel absorbed in those years went far beyond how to cut glass. He learned that measurement was sacred, that tolerances were not approximate, that if a part was supposed to be accurate to 1/100th of a millimeter, then that was the number, and anything else was failure. This philosophy would follow him for the rest of his career. After Jena, Deckel spent his journeyman years traveling through Germany, the Netherlands, and England, studying precision manufacturing techniques at various firms, including Siemens Brothers in Woolwich. In 1897, he landed in Munich, where he took a position at C.A. Steinheil and Söhne, a respected maker of astronomical instruments and photographic lenses. And it was at Steinheil that Deckel met the man who would change his trajectory entirely. Christian Bruns was an inventor with one obsession: the mechanical regulation of photographic exposure. In the late 1890s, photography had a problem. Emulsions were getting faster, plates were getting more sensitive, but the method for controlling how long light hit them was still basically pulling a cap off a lens and putting it back on. For long exposures on slow plates, that was fine. For anything faster, it was a joke. Bruns believed that a mechanical shutter built between the lens elements, one that could open and close with repeatable accuracy at fractions of a second, would solve the problem. He had already designed Steinheil's first leaf shutter in 1899. What he needed was someone who could actually build the thing to the tolerances his designs demanded. At the end of 1898, Friedrich Deckel, now 27 years old, opened his own mechanical workshop in Munich. He survived on subcontract work for a telephone factory and other local firms. But when he and Bruns formally joined forces in 1903 as Bruns and Deckel, the real work began. Their stated goal was simple: build a shutter that could reliably control exposure time down to fractions of a second. They were 32 and working out of a small Munich shop. Nobody outside the German optics community had any reason to know their names. In 1904, they introduced the compound shutter. It used a pneumatic escapement, a tiny air cylinder with a spring-loaded piston mounted across the top of the shutter casing. When the shutter fired, the blades opened, and the closing action was delayed by the piston forcing air through a small, calibrated hole. Adjust a cam via the speed dial, and you changed the piston's travel distance, which changed the delay, which changed the shutter speed. It could hit speeds from 1 full second down to 1/200th of a second with startling consistency. For the photographic industry, this was a leap. The compound would remain in production for over 65 years, with the last units manufactured around 1970 for large format cameras. Bruns left the company in 1905. Historical sources describe him as restless, an inventor who needed to keep moving. Deckel became the sole owner of Friedrich Deckel GmbH, but Bruns did not stop working on shutters. On his own, he developed something even better, a fully mechanical clockwork gear train that replaced the pneumatic piston entirely. No more sensitivity to dust, oil, or temperature. Pure geared escapement, like a tiny clock inside the shutter body. Bruns applied for the patent on June 6, 1910, but he never saw it granted. Christian Bruns died in 1912, and the German patent, DRP 258646, was formally issued on March 26, 1913, after his death. His son Heinrich continued a small firm, but the real story of the invention now belonged to Deckel. This is where it gets complicated. Carl Zeiss, the optical giant, recognized the brilliance of Bruns's design immediately. Zeiss acquired the patent outright and then licensed it back to Friedrich Deckel for production. The resulting shutter, introduced in 1912, was named the Compur, a portmanteau of compound and Uhrwerk, the German word for clockwork. It became the gold standard of the 20th century photographic industry. Every serious camera brand adopted it. Zeiss Ikon used it in the Ikonta and the Kontaflex. Rollei used it. Hasselblad used it. Kodak put it in the Retina. Voigtländer built the Besematic around it. Linhof used it in their large format systems. For decades, if a camera was worth owning, there was a very good chance the shutter inside was built in Munich Sendling at Deckel's factory on Plinganserstrasse 150. Under Deckel's leadership, the Compur kept evolving. The Compur Rapid arrived in 1935 with a top speed of 1/500th of a second. In 1951 came the Synchro Compur with flash synchronization. Then, at Photokina 1954, Deckel introduced the light value system, mechanically coupling the shutter speed and aperture dials so that changing one automatically adjusted the other to maintain the same exposure. It was elegant. It was clever. And it masked the fact that Friedrich Deckel had been quietly trapped. Because behind the scenes, Zeiss was not just a customer. They were the landlord, the banker, and the silent majority owner. Through dummy corporations and secret trusts, Zeiss had been buying up shares of Friedrich Deckel GmbH since 1910, when they first acquired a roughly 17% stake. They simultaneously purchased shares in Deckel's only serious competitor, Alfred Gauthier, the company that built the Prontor shutter. By 1931, Zeiss held a majority. By 1944, Zeiss secretly controlled nearly 80% of Deckel and a commanding stake in Gauthier. Two companies, one real owner, both believing they were competing for market share that Zeiss was allocating from behind a curtain. Friedrich Deckel, despite his genius, spent most of his career manufacturing products on licenses owned by the same company that was slowly absorbing his firm from the inside. The shutter business was a masterclass in precision manufacturing. But it was the thing Deckel built to make the shutters that would outlive everything else. In the 19-teens, the gears inside a Compur shutter were so small, the tolerances so tight, that no commercially available milling machine could produce them reliably. So Deckel did what Ernst Abbe had taught him to do. He built his own. He designed bespoke milling machines, pantograph engravers, and tool grinders specifically for shutter component production. Neighboring camera and optics manufacturers in Munich noticed the quality of Deckel's internal equipment, and they wanted to buy it. Sensing an opportunity, Deckel started selling his surplus machines to the trade around 1920. The machine that made his name immortal among toolmakers arrived around 1934. The Deckel FP1 Universal Tool Milling Machine. FP stood for Fräsmaschine, or more specifically, Stempelfräsmaschine, meaning punch milling machine, because it was originally designed to mill the complex male and female steel punches used in sheet metal stamping. What made the FP1 special was not any single feature. It was the system. The base machine gave you 300 millimeters of X travel, about 150 millimeters in Y, and 340 millimeters in Z, all driven through hardened gearboxes rather than belt pulleys, which meant enormous torque at low speeds. The vertical head could be removed to expose a horizontal spindle. You could attach a 360-degree swiveling angular head, a high-speed boring head borrowed from optical jig borer technology, or a corner milling head designed to reach inside tight internal cavities. Universal tables, dividing heads accurate to within 90 arc seconds. Optical inspection attachments. Every accessory locked into the same machine frame. One FP1 could replace an entire row of single-purpose machines. It was not a milling machine. It was a machining system. To understand what the FP1 meant to the trade, you have to understand what it competed against. In America, the dominant universal mill was the Bridgeport. Bridgeports were fast, affordable, and everywhere. They had higher top spindle speeds, and they were easier to buy. But a Bridgeport flexed under heavy cuts. The head could nod. The column could twist. A Deckel FP1, by contrast, was built like a bank vault. The dovetail ways were hand-scraped at the factory, a process where a skilled fitter removes metal by hand with a scraping tool, a few thousandths of an inch at a time, until the mating surfaces have full, even contact. It is the most labor-intensive and most precise method of creating a sliding fit, and Deckel did it on every machine. The Swiss competitors, Schablin with the Model 13 and Asiera with the F3, came close on precision, but neither matched the Deckel's accessory ecosystem. The British recognized this early. Alexander of Nottingham manufactured the FP1 under license as the Alexander Master Toolmaker, selling it throughout the Commonwealth. By 1945, approximately 4,100 FP1 units had been produced for the German war effort alone. By 1952, the heavier FP2 arrived, upgrading the spindle from Morse taper 4 to the SK40 standard that became an industry norm. The FP3 and FP4 followed for heavy industrial work. By 1965, over 50,000 FP1 units had been built. By 1972, Friedrich Deckel AG was the fourth largest machine tool manufacturer in West Germany, but before the machines became the company's future, they first served a much darker purpose. When the Second World War began, Friedrich Deckel GmbH was classified as a Rüstungsbetrieb, a critical armaments manufacturer. Civilian shutter production stopped. The entire factory in Munich Sendling was redirected toward building fuel injection pumps for BMW 801, a 14-cylinder radial engine that powered the Focke-Wulf 190 fighter. Over 61,000 BMW 801 engines were built during the war, and Deckel produced the injection hardware. The pump was an axial piston design with a rotating barrel and individual fixed-stroke pistons for each cylinder. Fuel metering was handled by a spill port mechanism machined to handle extreme pressures. The system worked in concert with the Kommandogerät, one of the most remarkable pieces of analog engineering ever built. It was a mechanical hydraulic computer mounted directly on the BMW 801 engine, and it automatically adjusted fuel flow, propeller pitch, supercharger boost, and ignition timing through a single throttle lever. Before the Kommandogerät, a Luftwaffe pilot managing a radial engine in combat had to coordinate multiple levers and gauges while simultaneously trying not to die. With it, one hand on one lever managed everything. The pilot pushed the throttle forward, and the Kommandogerät calculated the rest. Deckel built the injection hardware that fed this system, precision-machined components operating at pressures and temperatures that would destroy anything built to lesser tolerances. To meet production quotas, Deckel used forced labor. Thousands of men and women from occupied territories were brought to barracks near the Munich factory. By September 1944, over 120,000 foreign civilian workers, prisoners of war, and concentration camp prisoners were deployed across the Munich region, according to the NS Dokumentationszentrum. Deckel was one of dozens of Sendling industrial firms that drew from this labor pool. The extent of conditions and the specifics of camp administration are documented in the Munich City Archives and in Andreas Häusler's 1996 study of wartime forced labor in Munich's war economy, though certain operational details remain the subject of ongoing archival research. Inside that factory, one man was fighting back. Hans Hutzelmann was a German communist and anti-fascist who worked as a machine builder in Munich's industrial sector during the 1930s and the 1940s. In 1943, he became deputy chairman of the Antinazistische Deutsche Volksfront, or ADV, an underground resistance network. Working alongside a secret organization of Russian prisoners of war called the Brüderliche Zusammenarbeit der Kriegsgefangenen, Hutzelmann's group smuggled food to starving forced laborers, carried out targeted acts of industrial sabotage to disrupt the Luftwaffe's supply chain, and stockpiled stolen weapons for a planned armed uprising in Munich. His wife Emma organized alongside him. The Gestapo uncovered the network in January 1944. Hans was arrested, tried, sentenced to death on December 8, 1944, and executed by guillotine at Brandenburg-Gordon Prison on January 15, 1945. Emma was also arrested and imprisoned at Munich Stadelheim, but she escaped on July 31, 1944. She spent months hiding in the Isar Valley before being severely injured in an Allied air raid. Emma Hutzelmann died on November 27, 1944, in a Munich clinic, unrecognized by authorities. She was 37 years old. Today, a memorial stele at the Platz der Freiheit and an Erinnerungszeichen at Margaretenstrasse 18 in Sendling commemorate the couple. Meanwhile, Allied bombers were systematically destroying Deckel's Munich facilities. The factory was heavily bombed in 1943, and production was forced to decentralize. An independent firm called Aerostal Fluggereitebau, based in Cologne ports, and run by a director named Walter Schierberg, built injection pumps of the Deckel design in the Ofenkaulen, a network of former volcanic tuff caves in the Siebengebirge Mountains near Königswinter. The relocation was given the military codename Schlammpeitzger. Roughly 400 forced laborers from Eastern Europe, along with Italian, Czech, Dutch, Russian, and Belgian prisoners of war, were housed in 10 barracks and put to work assembling fuel injection pumps underground, hidden from Allied reconnaissance. That operation ran from late 1944 until early March 1945. A 2019 archaeological excavation by the Rhineland Regional Authority documented the barracks camp. After the war, Schierberg was tried for war crimes in Poland. He was freed on appeal in July 1949. If stories like this are the kind of thing you come to Trade Archive for, take a second to subscribe, because you are not going to want to miss what comes next. Friedrich Wilhelm Deckel did not live to see his company recover. He died on July 10, 1948, in Munich, just 3 weeks after the introduction of the Deutsche Mark that signaled Germany's economic rebirth. He was 76 years old. He was buried in the Waldfriedhof Cemetery. His wife Senta, née Bonneberger, whom he had married in 1902, survived him by nearly 20 years. Their two sons, Dr. Hans Deckel and Friedrich Wilhelm Deckel Jr., stepped into leadership of the company. The timing was almost poetic. Deckel died at the exact inflection point between ruin and resurrection. Within 5 years, riding the Wirtschaftswunder, the German economic miracle that rebuilt the country from rubble, the company employed over 3,000 workers and was producing shutters and machine tools at pre-war scale. His sons ran the business with the same engineering-first philosophy their father had instilled. In 1958, Carl Zeiss AG finally purchased Friedrich Deckel outright, ending the decades-long shadow ownership and at least making the cartel official. In 1961, the shutter division was formally separated and renamed Compur Werk GmbH and Company. In 1972, the machine tool division restructured as a public company, Friedrich Deckel Aktiengesellschaft. But the leaf shutter was dying. The Japanese camera industry, led by Nikon and Canon, had bet on the 35mm single-lens reflex, and the SLR needed a focal plane shutter, not a between-the-lens leaf shutter. The reasons were economic and mechanical. A leaf shutter sits between the lens elements, which means every interchangeable lens needs its own shutter. Or you need a complex coupling system like the DKL bayonet mount that Deckel developed in the late 1950s for Kodak, Voigtländer, and others. A focal plane shutter sits in the camera body. One shutter, any lens. Cheaper to produce, simpler to engineer, and more flexible for the consumer. By the 1960s, the market had shifted decisively. In 1976, Zeiss closed the Compur factory in Munich and consolidated the remaining leaf shutter production at the Prontor facility in Kalmbach. The product that had defined Deckel for 7 decades was finished. The machine tool division, though, was thriving, and it was about to face the biggest technological shift in manufacturing history. In the late 1970s and the 1980s, the world moved from manual machining to CNC, computer numerical control. Deckel attacked the transition aggressively. They developed their own proprietary conversational control system called Dialog, eventually running through versions Dialog 1 through Dialog 11. The difference between Dialog and a standard FANUC control was the difference between talking to a machine and programming one. On a FANUC, the operator wrote raw G-code, line by line, specifying every coordinate, every feed rate, every tool change in an abstract numerical language. On a Dialog-equipped Deckel, the operator answered on-screen questions. The control asked what shape you wanted to cut, what material you were cutting, what tool you had loaded, and then it generated the tool paths itself. Packaged cycles handled common operations. For a toolmaker who had spent 20 years feeling the handwheels of a manual FP1, who understood metal but not computers, Dialog was the bridge to the digital age without forcing him to become a programmer first. The FP-NC series, FP2-NC through FP7-NC, married the legendary FP frame to servo drives and these conversational controls, and they became workhorses across European tool rooms. Upgrading from one Dialog version to the next was not a software update. It required physically replacing circuit boards, which gives you a sense of how deep the proprietary commitment ran. But the economics were brutal. A German-made Deckel, built with hand-scraped dovetail ways, cast iron frames, and no-compromise gearboxes, cost significantly more than a Japanese machining center that could do 80% of the same work. Fanuc, Okuma, Moriseki, and Mazak were flooding the market with capable, affordable machines. Deckel's philosophy of building the absolute best, regardless of cost, had always been its identity. Now, it was bleeding the company dry. In a desperate move, Deckel merged in 1993 with its fiercest domestic rival, Maho AG. Maho had been founded in December 1920 in Franken, Bavaria, when a group of precision mechanics and an Augsburg merchant formed a drafting instrument factory called Meyer, Hormann & Sie. Over the decades, Maho had built its own formidable reputation, particularly in universal milling machines and simultaneous 5-axis machining centers. The logic was straightforward. Pool resources, dominate the European milling sector, fight off the Japanese together. What happened instead was a catastrophic culture clash. Two proud Bavarian companies, each employing roughly 3,000 people, each convinced their way of building machines was the right way, tried to merge under enormous financial pressure, while the post-Soviet economic collapse simultaneously destroyed their established export relationships in Eastern Europe. Markets that had been reliable buyers of German machine tools for decades vanished overnight. Just 1 year later, in 1994, Deckel Maho AG declared bankruptcy. The damage was staggering. Out of roughly 6,000 combined jobs, only about 1,000 survived. The Fronten and Geretsried plants remained open. Munich did not. Decades of institutional knowledge, the kind of knowledge that lives in the hands of machinists who spent 30 years on one type of machine, people who could hear from the sound of a cut whether a tool was wearing, vanished when those workers left the factory floor for the last time. For the German Mittelstand, the network of specialized family-influenced manufacturers that formed the backbone of the country's industrial identity, the Deckel Maho bankruptcy was a gut punch. Salvation came from Bielefeld. Gildemeister AG, a historic lathe and turning center manufacturer founded on October 1, 1870 by Friedrich Gildemeister, bought the operational remains. The merged entity became DMG, Deckel Maho Gildemeister. And this time, the combination worked. Deckel contributed high-precision milling DNA. Maho brought robust 5-axis architecture and the Fronten manufacturing campus. Gildemeister added world-class turning technology. Together, they had a complete portfolio. In 2009, DMG entered a strategic partnership with Mori Seiki of Japan, founded in 1948 by 3 brothers in Nara Prefecture who started in textile machinery before moving into lathes and machining centers. Cross-shareholdings turned into co-branding in 2013, and by 2015, Mori Seiki acquired the controlling majority at 52%. The German entity became DMG Mori Aktiengesellschaft. Today, it is one of the largest machine tool conglomerates on Earth, reporting roughly €2.5 billion in annual revenue from the German entity alone, employing over 13,500 people across 43 countries, operating approximately 17 production sites and over 100 sales and service locations worldwide. Their product catalog spans CNC turning, 5-axis milling, ultrasonic machining, laser additive manufacturing, and an integrated digital ecosystem called Celos. In September 2024, DMG Mori broke ground on a new European headquarters in Munich, the city where Friedrich Deckel started the whole thing in a small workshop with a telephone factory contract and a dream about shutters. There is one more chapter to this story, and it involves a car. Remember those fuel injection pumps Deckel built for the BMW 801 during the war? The axial piston design with the spill port metering? After the war, Deckel continued refining the technology and developed a simpler variable stroke metering concept. In the early 1950s, Georg Schaefer, the owner of FAG Kugelfischer in Schweinfurt, formed a new entity in Munich called Schaefer Einspritztechnik, and the injection business migrated from Deckel to Schaefer's operation. You can trace the handoff in the stamps on the pumps themselves. The earliest post-war units read Friedrich Deckel. Then they read Schaefer Pumpe. Then Kugelfischer Schaefer Pumpe. The name changed, but the engineering lineage did not. Kugelfischer perfected a cam-metered mechanical injection system, and by the late 1960s, BMW was ready to put it in a road car. The BMW 2002 TII, introduced in 1971, used Kugelfischer mechanical fuel injection, a direct descendant of the wartime aircraft pump adapted for a 4-cylinder inline engine running on city streets, instead of at 20,000 feet. BMW built over 64,000 cars with that injection system between 1969 and 1975. Porsche used it in the 911 RS and RSR. Ford used it in European touring car racing. Lancia used it. Peugeot used it. And in the early 1980s, a servo-controlled version of the Kugelfischer metering system fed fuel to the BMW M1213 turbo engine in Formula One, an engine that produced over 1,300 horsepower on qualifying boost. Robert Bosch acquired the injection business in 1975, But the engineering lineage ran straight back to the Munich workshop, where Friedrich Deckel first solved the problem of metering fuel into a 14-cylinder radial engine for the Luftwaffe. Today, if you want to buy an original Deckel FP1, you will pay roughly what you would for a decent used car. A dealer-restored machine with a full set of tooling and accessories commands a serious premium, and dealers ask roughly 3 times what a private seller would. The machines weigh between 500 and 800 kilograms, and moving one into a basement workshop requires planning, a furniture dolly, and usually a favor from someone who owns a van. There is a dedicated sub-forum on Practical Machinist called Deckel, Maho, Sierra, Abini Mills. The hobby machinist community runs deep. YouTube restorers like Stefan Gotteswinter have built substantial followings documenting FP1 teardowns and restorations in forensic detail, every bearing, every gear, every thou of backlash in the lead screw. Watchmakers love them because no other machine at that size can hold the tolerances required to cut escape wheel teeth. Model engineers love them because one FP1 can make every part for a miniature steam engine. Collectors call the obsession Deckel disease, and there is no known cure. The Deutsches Museum in Munich still displays Deckel machines, including an FP1 bearing serial number 29817, dated April 15, 1954, alongside a horizontal milling machine from 1919 that the museum calls the daddy of all the Deckels. Meanwhile, in a quiet corner of Munich on Weissenseestrasse, a company called Compur Monitors GmbH still operates, tracing its corporate lineage directly to Friedrich Deckel's 1898 workshop, now building gas detection systems instead of camera shutters. Friedrich Wilhelm Deckel was the son of a farmer who learned precision from Ernst Abbe, built the shutter that defined photography, built the machines that built the modern world, and died 3 weeks after the currency reform that would have let him see all of it come back. His name disappeared into the corporate genealogy of DMG Mori. His shutters went obsolete. His factory was bombed, rebuilt, merged, bankrupted, and sold. But the standard he set in that Munich workshop in 1903, the idea that a tolerance is not a suggestion, still drives the cutting edge of global manufacturing. And somewhere in a garage or a basement workshop right now, a machinist is running a Deckel FP1 that was built before their parents were born, and it still cuts to spec.